All right. Advanced Algebra 1, Topic 9, Section 5, Completing the Square. Completing the square is used when a function is in standard form and I want to move it to graphing form. Okay. It's also a way to solve quadratic equations. It's not a way that's readily used to solve quadratic equations, but it is a method that can be used for that. It's also, if we complete the square on the standard form of a quadratic equation, we get the quadratic formula, which is yet another way to solve quadratic equations. Okay, so here's what needs to happen to complete the square. First, this one is we already have it set up. Okay, and I'll go through the process of what we would do on another example. But technically, all we need to do here is factor this thing on the left, and it's going to factor. It's a perfect squared trinomial, and which is a very important part of completing the square, is knowing and understanding what a perfect squared trinomial is. And what a perfect squared trinomial is a trinomial that when I factor it, I get something squared. Okay. You know, this would factor to x plus 5 times x plus 5, or x plus 5 squared. When we look at this, this would factor to x minus 3 times x minus 3. So we would want to write that when we're completing the square as x minus 3 quantity squared. And then this is why we practice taking the square root of both sides, because that's how we're going to solve this now. We're going to take the square root of this side and the square root of this side. And we get x minus 3 equals plus or minus 4. And then we would add 3 to both sides. So x is 3 plus or minus 4. And sometimes this will be a radical, and we'll say, there we are, as long as that's in simple radical form. Obviously, 16 is a perfect square, so our answers are 3 plus 4, which is 7, and 3 minus 4, which is negative 1. And that's it. What makes it difficult is they're not always going to set it up for us in that way. And so the first thing we do is we move this constant to the other side. So I'll have x squared minus 14x, and I'm going to leave some space. It equals negative 16. Now, this is our linear term because it's to the first degree. And I'm going to take half of the linear term. So half of negative 14 is negative 7. And I'm going to square it. And I'm going to add it to this side, and I'm going to add it to this side. But when I add it to this side, I'm going to put plus 49, because that's what negative 7 squared is 49. The reason I leave it like this on this side is because this tells me that this factors to x minus 7 quantity squared. Okay, I don't have to think about it. I don't have to do anything. And then negative 16 plus 49, or 49 minus 16, is 33. Okay, now I take the square root of both sides. And over here, I get x minus 7. And over here, I get plus or minus the square root of 33. And then to get x by itself, I add 7. So x is 7 plus or minus the square root of 33. And that's it. That's your answer. Okay. So what do we do first? We move that 9 to the other side. We have x squared plus 10x, leave some space, equals 9. And then we take half of 10, which is 5, and we square it and add it to both sides. This factors to x plus 5 quantity squared. This factors to 34. Now I take the square root of both sides. Boom. I get x plus 5 equals plus or minus the square root of 34. It cannot be simplified. Subtract the 5. And there you have it. I'm going to actually skip this fourth example. I'm going to move on down to this fifth example, which is going to be difficult to say the least. One of the rules that I have not told you, if we go to complete the square here, minus 3x, leave a space, move 15 to the other side. One of the rules I haven't told you is that the coefficient of x squared has to be 1 in order for this to work. Okay, so I factor out that 5, I get x squared minus 3/5 x, leave a space, equals 15. And now when I take half of the coefficient there, half of 3/5 is 3/10. So plus 3/10, and I'm going to square it in there, okay? Which means that in those parentheses, I'm adding 9 over 100. When it comes outside of those parentheses, it's going to get multiplied by 5, which means I'm really adding 9 over 20. So I add 9 over 20 over here. And then 9 over 20 plus 15 is, that's what I thought, 309 over 20. And so I'm going to have 5 times the quantity. This is going to factor to x minus 3/10 quantity squared. I would divide both sides by 5, which means I'm going to have x minus 3/10 quantity squared equals 309 over 100. Okay. Now I take the square root of both sides. Boom, boom. And I get x minus 3/10 equals the square root of 309. Oops, I forgot my plus or minus. Over 10. Because I take the square root of the top, square root of 309, and I take the square root of the bottom, square root of 100 is 10. Okay, that's the, and now I add 3/10 to each side. 3/10 plus or minus the square root of 309 over 10. And I have a common denominator. If I wanted to, I could write that as 3 plus or minus the square root of 309 all over 10. And when we go to use the quadratic formula to solve these things, this is the form we're going to put it in. The 3 plus or minus the square root of 309 all over 10. And that's coming up in the next section. So anyway, the whole point of completing the square, as I said, is to change this from standard form to graphing form. Here's how I do that. I take the x squared minus 8x and I separate it from the 11. And now I'm going to take half of this, which is -4, and square it And so I'm adding 16 to this side. Because I'm staying on the same side, if I add 16 here, I need to subtract 16 here. Okay? If I were adding to the other side, then I would have done that to the other side, obviously. So this factors to x minus 4 quantity squared, and 11 minus 16 is minus 5. So we just changed that equation from graphing form to standard form, or I'm sorry, other way around, from standard form to graphing form. And now I can see that the vertex is 4, -5. The axis of symmetry is x equals 4. The range, this opens up, so it's x, my goodness. Y is greater than or equal to -5. I can graph this thing. The y-intercept is 0, 11. I believe it is going to have some x-intercepts, but I don't think they're going to be whole numbers or integers. So on and on we could go. All right. When there's a coefficient in front of the x squared, it gets a little tricky again. I'm going to take it out of the first two terms. So I'll have x squared minus 10x. And I'm going to push that 35, pretend it's out there. It's not part of what I'm doing right here. Now I'm going to take half of 10, which is -5, and square it. And so what I'm adding in here is 25. When it comes out, it gets multiplied by 2, and that makes it 50. And I'm adding 50 in here, which means I need to subtract 50 over here. And so this factors to 2 times the quantity x minus 5 squared. And then 35 minus 50 is minus 15. So again, we can look at it. We can tell you what the vertex is, opens up. That 2 is going to make it a little bit skinny, you know, etc. and so on. Okay.